What is the role of the CLR within the T-SQL is a question that I asked you at the beginning, and simply we can have a look on the role of the CLR based on the definition. The common language runtime, it's a stored procedure that has to be created, stored within the backend, which is the SQL Server, the DBMS itself, and it has a capability to read variables variants as input. It has the capability. This is not mandatory, and it deals with the SQL Server itself, and it sends out the results and the outcomes to the front end API. So it is a stored procedure to deal with the SQL Server from the SQL Server itself for security purposes, to hide, to obscure its functionality from the front end. It sends only the executed query results. It does not show the structure or the body of the CLS stored procedure to the front end users for security purposes mainly. So, precisely and briefly, the CLI is a stored procedure generated and stored in the back-end technology, back-end DBMS, back-end software, which is the SQL Server in question here in our view. It works and it acts similarly like the normal stored procedure, or the normal standard stored procedure from the front-end generator API. As simple as that. So we continue with the enhancement of the T-SQL to our surrounding environment. So once you have any doubt or any question, you just raise that, please. I'll be passing through step by step, and whenever you have actually a request, stop me at that level, and I will be at the level of answering your question. So here at this level, let me just start from here, from this presentation. The added value, one of the added values that the T-SQL has presented to us is the use of predefined, we may say, functions, procedures, or namespaces, classes, or things like that, that they are actually ready to be utilized by the developers and provide results to the end users. The table valid parameters is one of the technologies that the T-SQL has enhanced, has supported, has provided. This T-SQL is one of the utilities that helps the users to act with a graphical interface to generate content, to manage and to manipulate the content mainly. Table valued parameters is a sort of a hoster to hold values with specified types, and to be called and used by different actors, like stored procedures or user-defined functions. They will be actually also used and stored to be utilized again and again and again with the front end. Once we talk about stored procedures or those user-defined functions, they are all to be stored. Okay, the architecture of the table valued parameter is to be customized. It has to be matched the architecture of the entities the stored procedures or the user-defined functions are manipulating. Yeah, it has to match the entity architecture in order to match the rows and the columns, the records and the fields. The concern here actually, and the security issue that the TVP, table valid parameter, imposes once we talk about the regeneration of the tables as a value holder, value hoster, to have the same architecture of the inner and the database entities in order to make actually a front-end solution to avoid exposing the inner entity architecture, something like that. But it has to actually to check usually for the case of the overloading. Why? Because we may generate objects with the same names, with the same architecture, with the same body, let's say, yes. And this imposes an overloading issue, overloading the technology, the overloading, the polymorphism. Thus, it has to be actually preventive. The users, the developers, once they are actually generating TVPs, they have to be preventive and taking care of this concern, the overloaded. We said that, and we insist on that, that the TVPs, they have to be utilized from within. They can be called by the stored procedures and user-defined functions. And one of the benefits is that it would be able to be utilized again and again and again and again, reusability. So those CVPs, they have to be utilized again and again, yes, within the body once they are needed, once they are needed. And the schema actually of a TVP is essentially maintained in the sense of once you generate a TVP and you call it again and again within the body of the program, you just need to update once needed. You just need to update the portion where you generated the schema, this TVP, and that's it. Everything and every call inside the body would be automatically updated. So this is why we say that it is centrally maintained. Centrally maintained means actually only one focal point. But the developers has to take care of. And the other calls, the other instances that would be automatically updated upon the update of the central declaration. An example, and these before actually taking the example, you have to consider that the TVPs, they are given the exception. What is the exception? The fact of being centrally maintained. Why? Because we may talk about the common table extensions, the CTEs, the common table extensions, the CTEs, which are not having the capability to be centrally maintained. Once you are using common table extensions, once you are utilizing them in more than one location in your program, if you need any updates, you have to update all the availabilities or all the instances. All you have to pass by them one by one. So this is another advantage of this TVP, table valued parameters. It's a clear view. Okay. Syntax for an example. Creating and declaring a TVP. Here we are declaring two data types, two standardized data types, just as per an example, to utilize them again and again upon the program in order not to declare again and again and again and again. We create a type. See, create a type, and this type here, in the first one is an int, not null. The second type is a varchar that has a size, 100 characters. So the ID or the location, they are user defined, and they are to be utilized later on in the program again and again and again. They are the ones to be called again and again and again. We will not write any int, not null. No, we just say ID. That's it. ID. We will not write any varchar 100. We will just say no location. The program will know this type from now on. At this level exactly, I'd like you to have a look. Actually, this is in SQL Server. I'd like you to compare those two statements. See here, we have a statement, semicolon, and then this is another statement, another semicolon. Okay, we terminate. I want you to compare those two statements with the Oracle, because this is an SQL Server. This is an SQL Server. I want you to compare those two statements with the Oracle version, how we write the type, how we create the type in an Oracle. It's the same way. Actually, we need an ID as an int, not null, and the location as an as a varchar also with the size 100 characters. Compare them and see what are the differences. Can you just have a look, please? Simple. Yeah, here actually the main concern and the main view here is that the main difference in between those two, whether we are declaring creating the types for SQL Server, creating the types for the Oracle, is that they are to be generated as objects with the Oracle. They have to be generated as objects. There is another syntax, means here actually we have to not straightforward mention that they are actually ints or varchars. They are objects as we specify the data type, the actual data type. Objects as the actual data type. You need it either it's int or varchar or any other. Those are examples only. So here I come back before I continue. The alias is mentioned here. The alias mentioned here is the nomination of the data types. Here the ID is the alias for what? Alias for int not null. Location is an alias. Alias for what? For varchar 100. Aliases. Okay. A TVP as an example, we are creating a type now as a table. We are creating a type as a table, not as an int or as a data type. No, as a table, and the table has to have an architecture. We were talking about the architecture earlier. We were talking about the architecture earlier. Here it is. You are presented the architecture earlier. Okay. Now we create data type. A TVP as a table. We are going to create new type as a table. Table valid parameter absolutely true. We have to know that the table variable are actually like the temporary tables or the common table extensions. They actually be actually utilized as, yes, they not as, but they can be utilized in any scenario in the sense of they are normal as a normal data type or as a normal object or things like that. Once you need them, as if you are needing the original component. So we are going to call a table again and again within a user-defined function or even another portion in the program. So the syntax how to create the schema for this TVP is as follows. We create a type for sure. Create type. Like we are declaring it, create type as for an int or create a type for the varchar. The same. So the keywords they are create type. We give a username, which is not username. We give a user-defined name. Here in this example, customer UDT, customer user-defined table. As table. So we create type, we give the name as table, as table. The table has to have an architecture, a structure. So this is it. In between parentheses, we have 3 columns, 3 fields. The ID is int, the customer name is nvarchar, 50 characters, and the postal code is an nvarchar, also 50 characters. So we have 3 fields: ID, comma, customer name, comma, postal code. It's a table with 3 fields. We are just generating a type. So this is a type that can be utilized later on for different purposes. The question here actually just like I'm going just slowly just to make you be comfortable and feel that you understand this concept, this technology. The purpose here actually is that the question comes here: why we are generating table types or types as tables? We just use the table straightforward and that's it. No, actually, because the size and the use later on, it can be different, because we may use a table from within a complex query, not a simple query, a complex query. Means we need more than one table in just one query, more than one table in one query for a reason or another also. So we may use the types. It's much more easier and smaller inside. Smaller inside. You not write much code. And remember, this is an example only. So those are 3 fields only. We may have tons of columns of fields, 10 fields, for example. So it is not feasible to rewrite them again and again and again and again. It is okay to just mention the name. Customer Unity. Full stop. The name of the table type. Any questions here, please? Remember, when we compare the table valid parameters and the common table expressions or extensions, actually they are similar in spirit, which they are going to have an architecture to store values. Yet a difference in between this and that is that the CTEs, which is the TVP, the TVP, the table valid parameters, they are a very good example of reading the architecture of the original type, and then after shortly be generated, then only the names to be utilized again and again and again. So if we want to do any modification, we just control the main declaration, the main declaration. But for the context of the CTEs, there are usages that we need common table expressions like this one here. So the CTEs, they have the same architecture as the TVP, yet they are not centralized. It means once you need them again and again and again, you just use the tables again and again and again. So it's a simple table expression here, extension here, or definition here, or declaration. All is correct. Before I continue, any questions, please? So great, since you don't have any questions, we continue. In a program where we need actually the sort and functionality to be utilized or set, originally we need more than one, let's say, solution. More than one query, not solution. The query to read the original, not sorting, but any complex entities readings needs from us more than one query to read, update, and store, commit, something like that. So more than one command. This is what the original and traditionally created databases. This is no more the case with the use of the T-SQL. It is not the case. It is not the solution. It is not what we used to see now with the adaptability of the T-SQL, because we can create a single stored procedure with just 2 TVPs, the parameters, in just one shot, that they play the role of updating one field or one, let's say, record at the same time. And this record is actually the mixture of both entities. So I read it again. We can create a single stored procedure with just 2 TVPs. And here at this level, one for the order and another one for the details, because those are 2 tables available in our book now. This is a print screen from the solution in our book, no more. The order and the details, they are 2 tables I'll go further and I come back. Here's the order and the details. Those are, this is the order, I believe, and this is the details. We come back. Okay. The use of the TVPs does not mean that we are solving the issue of secure coding, writing secure codes. No, there are limitations. Limitations means we will not be able to do everything once the TVPs are applied. Once we are creating a table type, we will not be able to do everything, all the queries we can pass. No. As for example, you cannot make an alteration, a modification of the content. To alter a table, we cannot, because we do not have the original table. You have an image, an instance, a view only of the table through the TVP. So modification are not successful, and they will not be able to be done, to be executed. Alteration means to alter means to modify, to edit. This is a SQL query, alter table. It's a SQL query, alter table. An example of procedure, an example of procedure here, an example of procedure that is having two user-defined tables, two table types. One is on the first entity, given the name order, and the second one on the second entity, which is the details, the order details. Both of them, they are read only, read only, and they would do as here. See the as here, as what? Query number 1, query number 2, query number 3, and queries as many as you need. That's it. Those two queries, they are insert. Those two queries, they are for insert. We cannot write alter. We cannot pass an alter here. We cannot pass an alter table here. We cannot. It would not be successful. You have to use a simple query. You have to use a different transaction, not this case, not the TVP. So alteration is one of the limitations that the TVP cannot do, cannot trespass. Any questions for this syntax, please?
No, I'm stuck.
Okay, great. So great. Since we are talking about the types, the SQL Server has defined 4 specific data types specifically to be utilized within the SQL Server only. So using the SQL Server, the SQL Server has defined 4 new data types that they can be utilized to define straightforward a variable with the data type, whatever the variable is. Those 4 data types are the datetime2, and the datetime offset. They are talking about the timing concept, but with different syntax, with different syntaxes of representation of the numbers and dates. So we may write int A, int B, int C in the program. And at the same time, you may write date A, date B, date C, and so on, date as a data type. Also, you may write, if you need, time A, time B, and so on. If you need them, time. You may write date time to A, date time to B, date time to C, and so on if you need it. You may type date time offset 1, A, date time offset 2, date time offset B, date time offset C, and so on. So those are 4 data types defined by the SQL Server to the SQL Server users, whether they are actually those commands are utilized or not, they are adopted or not. But this is the case of using the defined data types. Data type talk, data type. Okay, we may actually from a distribution, the SQL Server nowadays, it has the capability to declare variables to be utilized within programs. Declare variables, so we can pass as if we are writing int A, int B, int C in a program. But the syntax is different. We do not type int A or date A or sha A or varchar string A. We don't do like that. So within the SQL Server using the T-SQL, we declare this way: declare a keyword and the variable name. We precede it with an at, and then after at the end the data type. So I repeat: to declare a variable DOB here, date of birth, DOB. This is a variable. How I knew? Because of this arbas, this at before it. So this is a variable. Is it correct, the syntax? Yes, because you have to declare it at the beginning of its use, and you give the data type, the real data type at the end. Simple. We do the same thing for the second variable, third variable, n variables, whatever the variables you have, how many the number is, the same way. Once you are creating a variable to receive values, you declare the same way. You use the keyword declare at the end the data type. What is the data type for that? In between, you give the username defined actually variable that you are going to use, and you precede it with what? With this arrobas. Simple. So in a database-based project, anything you see that is, I repeat, in any database-based project, any use of any name that is preceded with an arrobas, that is a database property is utilized. He's getting out from the job or something like that. So whatever. This is a declaration. This is a declaration of a variable that is going to be utilized for future. It is declaration only. It is a declaration. You have to respect the syntax. Any questions, please? At this level?
No, Mr.
Okay, I'll take the attendance. Give you the recording just in a while.